Namaste, welcome to all. Today we discuss and learn some interesting things about areas of parallelograms and triangles. What is area? It is an area of a figure is a number associated with the part of the plane enclosed by the figure, and it consists of boundary and interior regions. Okay, if you take any polygon region means what we need to do, we have to take its polygon and it is union of its boundary and interiors. Okay, if you say circular region means boundary and interior together, it is circular region. Okay, similarly triangle, boundary and interior together, it is triangular region. Rectangle, boundary and interior together, rectangular region. Square, boundary and interior together, square region. We are taking a quadrilateral. Straight away we cannot find the area. So what we will do? We'll take a diagonal. Okay, it divides the quadrilateral into two triangles. Okay, now see, we are having some properties. Okay, area of figure is equal to sum of the squares of finite number of parts in it. Okay, here our quadrilateral region is made up of two non-overlapping triangular regions. No, then how will you get the area of area of quadrilateral region? That is by adding the area of triangular region 1 and area of triangle region 2. Okay, these two areas you have to add to get the area of quadrilateral region. And another important property is the area of two congruent figures are equal. Okay, if two figures are congruent, their areas are always equal. But two figures with equal area need not be congruent. Okay, let us take a rectangle. Okay, here see this rectangle. No, here I have taken unit squares in it. Okay, to find its area, I have taken unit squares. And also I have highlighted this unit squares. How will you find the area of unit square? 1 square centimeter it is. How it is formed? It is the area formed by the square of side 1 centimeter. Okay, like this, how many unit squares are there means how many rows are there here? First, 1, 2, 3, 4 rows are there. How many columns are there? Okay, 9 columns are there. So how will you get its area? 4 times 9. So area of this rectangle is 4 times 9, that is 36. One more rectangle I am taking here. Okay, here see. How many rows are there? There are 9 rows. See, if you count, there are 9 rows. How many columns are there? There are 4 columns. Okay. And how will you get this area? 9 times 4. If you have these two rectangles, they are congruent. See. Okay, their orientation may be different, but they are congruent. Okay, if they are congruent, their areas are equal. 4 times 9 or 9 times 4, you will get 36 only. But if you take some square like this, okay, here number of rows are 6, number of columns are 6. So totally how many unit squares will be there? 6 into 6, 36. Its area is also 36. Here rectangle area and square area are same, but they are not congruent. Their shape is not same. Okay. So above result, we have given examples. Now, another important thing we will learn is figures on the same base and between the same parallels. Okay. When two figures are on the same base and between the same parallel means two conditions are there. The two figures should have same common base, that is one side should be same, and the vertices opposite to the common base of each figure lie on the line parallel to the common base. We'll give some examples and non-examples also. Here, see. If you see ABCD is a rectangle and ABXY is a parallelogram, they are on the same base AB, and the opposite vertices you see DYCX, they are on the same line parallel to the common base. Okay, this rectangle and parallelogram are on the same base and between the same parallels. Similarly, one more examples we will discuss. Here ABCD is a parallelogram and ABP is a triangle. They are on the same base C, that is AB, and the opposite vertices of each figure will lie on the same line C, DC. Okay, therefore this parallelogram and triangle are in the same base and between the same parallels. Now we'll see the non-examples. Okay, here ABCD is a parallelogram, PQRS is another parallelogram. Here first condition only not satisfied. See, PQ and AB, okay, they do not have common base C. Common side, one side should be common. So both this parallelogram, we do not have common side on this side or this side. So first condition only not satisfied, even though second condition is satisfied. One more see, ABCD is a parallelogram, ABP is a triangle. Now first condition is satisfied. They are having the common base. One side is common. But see, the opposite vertex is not lying on the same line, which is parallel to the common base. Second condition is not satisfied. So they are also, it is also a non-example. Now we will discuss parallelograms on the same base and between the same parallels. Okay, here we have taken two parallelograms, that is ADRS and PQRS. They are on the same base SRC and lying between the same parallels, that is SR and AQ. Here see, the angle SAP here is equal to RDQ. Why they are equal, we'll see. Okay, because they are the pair of corresponding angles formed by the transversal AQ and the parallel lines AS and DR. Okay, and one more SPA and RQD are also pair of corresponding angles formed by the transversal AQ with the parallel lines SP and RQ. Okay, see, if you, in these two triangles, two angles are equal. If one more side is equal, we can apply the congruency criteria. So here PS side and RQ side are equal because pair of opposite sides of parallelogram are equal. Okay, now see, these two triangles are congruent by AAS congruency criteria. If they are congruent, their areas will be equal. Okay, by area congruency axioms. Just now first slide only we have told the properties. Okay, now see, parallelogram, you take ADRS. It is formed by the non-overlapping SPA and PDRS. Then its area will be equal to sum of SPA and PDRS. Now see, already you have proved SPA area will be equal to RQD. So you can replace SPA with RQD. Now if you add RQD and PDRS, you will get the area of another parallelogram, that is PQRS. Now we have showed area of ADRS is equals to area of PQRS. That means we have proved that parallelogram on the same base and between the same parallels are equal in area. Using this, one more important result we can prove is area of parallelogram is the product of any of its side and the corresponding altitudes. Okay, and one more result will prove area of triangle is half of the product of any of its side and the corresponding altitude. We'll take one triangle, ABC triangle we have taken. AP is the perpendicular drawn from A to BC, perpendicular shorter distance. It is also altitude. It is also called altitude. We have to do some construction. We have to draw AD equal to BC and BC equal to AB. Okay, here see. Here we have formed ABCD, a parallelogram, because both pair of opposite sides are equal. A parallelogram is formed. And see, already two sides are equal. AC is the common diagonal. For what can you say about these two triangles, ABC and ADC? Okay, they are congruent by triple criteria. Congruent means their areas will be equal. Oh, here one more result we have proved. What result we have proved? the diagonal of parallelogram, what it will do, it will divide the parallelogram into two triangles of equal areas. ABC area will be equal to CD area, that will be equal to half of the area of the parallelogram ABCD. This can be taken as first condition. And also you see, BC is the base and AP is the altitude of the parallelogram. Then what can be the area of the parallelogram? Base into altitude, no, corresponding BC into AP, we can say. This is second condition. From 1 and 2, what you are having? Area of ABC is equals to area of half of ABCD. And ABCD is BC times AP. So ABC area will be equal to half of BC times AP. We have proved. Hence, we have proved the result. Area of triangle is half of the product of any of its side and corresponding altitude we have proved. Next is using this is very important formula. Using this, we can get the area of quadrilateral, area of trapezium, and area of rhombus also. Area of quadrilateral, first slide only we have seen, we have to take diagonal, which will divide the quadrilateral into two triangles. And we should have two altitudes. Then area of quadrilateral is half of the product of one of its diagonal and the sum of the two half sets. And area of trapezium, you know, one pair of opposite sides are parallel, and you should know the height distance between the two parallel sides, that we will take it as height. Then area of trapezium is half of the product of its height and the sum of the two parallel sides. Rhombus, we know all sides are equal and you'll be having two diagonals. And how will you get area of rhombus? It is the product of it is the half of the product of its diagonal. Next, parallelogram and triangle on the same base and between the same parallels, we'll see what happens. Here ABCD is parallelogram and ABP is a triangle. They are on the same base AB and between the same parallels AB and DC. Here we have to do some construction. Through B we have to draw BQ parallel to AP you have to draw. And when the DC line is extended, this will meet at Q. Okay. Now see, ABQ is a parallelogram because already these sides are parallel. AB and this side is parallel. And now we have, by construction, AP is parallel to BQ. Okay. Therefore, both pair of opposite sides are parallel, means it is a parallelogram. Then this PB is diagonal. What it will do? Diagonal will divide it into two congruent triangles. So this area, APB area, will be equal to QPP, and that will be equal to half of the area of parallelogram. Next is this ABCD and ABQB. Okay, they are QP. They are on the same base AB and between the same parallels AB and DQ. Therefore, just now we have proved area of these two parallelograms will be equal. ABCD and ABQP are equal. Okay, using 1 and 2, what you will get? Okay, here this area is equal to half of ABQP and this ABQP is equal to ABCD. Therefore, area of triangle is equal to area of triangle APB is equal to half of ABCDC. Okay, so what we have proved, area of triangle is half of area of parallelogram if they are on the same base and between the same parallels, then only. Now triangles on the same base and between the same parallels. Here we can prove this because here we will use what and all result we have proved earlier. Okay, here ABC and DBC, these two triangles are on the same base and between the same parallels. Okay, now we have to do construction. What constructions we have to do means we have to draw CE parallel to AB and ABF parallel to DC. This construction we have to do. And this, see how we have to draw. No, we have to do construction in such a way that this all will fall on a same line, AD. Okay. Now parallelogram. You take the parallelogram ABCE parallelogram and another triangle FBCD you try. They are on the same base BC and between the same parallels BC and FP. Therefore, their areas will be equal. And one more triangle you take, ABC triangle you take and FBC parallelogram you take. They are on the same base BC and between the same parallels BC and FE. Therefore, this triangle area will be equal to half of the FBCE. Similarly, another triangle you take, DBC triangle you take, and the parallelogram ABCE you take. They are on the same base BC, and between the same parallels BC and DE and FE, sorry. Therefore, this triangle area will be equal to DBC will be equal to half of ABCE. Now using 1, 2, 3 results, okay, what you can prove? Okay, already these two parallelograms are areas are equal, you have proved, and this area, these two triangles areas are equal to these two parallelograms. Then using 1, 2, 3, what you can say? These two triangles areas are equal. ABC area is equal to DBC. Okay. Now, if two triangles are on the same base and between the same parallels, their areas are also equal. Okay. Now see, one more result we can prove here. Here for these two triangles, PBC is a common area. If you reduce this PBC from both the triangles, what you will get? From ABC, if you reduce PBC, we get a PAB triangle. From this triangle, if you reduce the common region, what you will get? You will get this PDC. You have proved that these two triangles areas are also equal. Even though they are not congruent, their areas are equal. Now we see area of triangle formed by joining midpoints of the sides of a triangle. Okay, one challenging problem we are doing. We have to take a triangle ABC. We are taking midpoints D, E, F on the sides BC, AC, and AB respectively. Here see, D and E are midpoints of BC and AC respectively. Then you can apply the midpoint theorem. Then it will be the DE line will be parallel to AB and DE will be equal to half of AB by midpoint theorem. This will prove in quadrilaters chapter. Also see, here see, DE will be equal to AF. Why means, see, F is midpoint of AB, then AF will be equal to half of AB. See, DE equal to half of AB and AF is equals to half of AB, then DE will be equal to AF. Okay. Next, see, already they are parallel. Now they are parallel, and now we have proved that they are equal. If one pair of opposite sides are parallel and equal, then AFDE is a parallelogram. Okay. If it is parallelogram, EF diagonal, what it will do? It will divide the parallelogram into two triangles of equal area. Then area of AEF will be equal to area of DEF. Okay. Similarly, we can prove area of BDF will be equal to area of DEF, and area of CDE is equal to area of DEF. See, all these triangles, AEF area and BDF area and CDE area are equal to DEF. So are equal to each other. Now, how will you get the area of triangle ABC? We have to add all these four areas, four triangle areas, four non-overlapping triangle areas we have to add. But all these areas are equal to areas of DEF. So we can replace with DEF. Okay. Now, how will you get area of triangle ABC? We have to add area of triangle DEF for 4 times. 4 times area of triangle DEF. Now, how will you get area of DFC? It will be equal to 1/4 of area of triangle ABC. Therefore, area of triangle formed by midpoint, by joining the midpoints of the sides of triangle will be equal to 1/4 of the area of the given triangle. Isn't it? This result is very interesting, no? Similarly, some more interesting results you can prove. That is, if you take a median in a triangle, median means it is the line segment joining the vertices to midpoint of opposite side. Here AD is the median drawn from A to midpoint BC. What it will do? That median will divide the triangle into two triangles of equal area. That means that AD, what it will do? It will divide the triangle into ADB and ADC. You know that areas will be equal to half of the total area. Okay, and also if you draw medians, okay, we have drawn medians AD, BE, CF. AD is median drawn on BC, BE is median drawn on AC, and CF median drawn on AB, you think. Okay, there are medians. These three medians will intersect at some point G. Then what it will do? you'll get three triangles C, AGB, BGC, and CGA triangle. This all areas will be equal. These three triangles areas will be equal to 1/3 of total area. Okay, this and all result can be proved. Okay, now we can also verify the Pythagoras formula. Okay, first we have to draw this diagram. Okay, see here ABC is a right angle triangle, right angle at A. Okay, we have to take squares. AB, this square you have to take ABDE one square on, and BCFG another square, and ACHI is another square. These three squares, how they are constructed means they are constructed on the sides AB, BC, and AC. Okay, now you have to draw one line segment AX perpendicular to GF meeting BC at Y. Okay, and also you have to join CD, you have to join BH, you have to join, and you have to join AG and AF also you have to join. Okay, all these line segments you have to join. Now see, here DBC and AGB, they are congruent. Why they are congruent? I'll tell you. Here BD and AB sides are there. They are the sides of square ABD. So they will be equal. And here see, this one side is BC here for this triangle, first triangle, DBC triangle. For another triangle, BG is side. These two are the sides of square BCFG. They will be equal. Two sides, two corresponding sides are equal. Their included angle also equal. See, here DBC is equals to ABG. Why they are equal means here 90 degrees plus ABC. Okay, here also 90 degrees plus ABC. So this DBC angle and ABG angle are equal. Therefore, by SAS congruency criteria, these two triangles are equal. Okay, if they're congruent, then their areas are equal. No? Okay, next see. This triangle, that DBC triangle, and you take the square ABD. They are on the same base BD and between the same parallels BD and CEC. C is a straight line actually. Why? Because this side 90 degrees, this side 90 degrees. It is a straight line. Okay. Now this triangle and that square are on the same base and between the same parallels. Then the triangle area will be equal to half of the square area. Similarly, ABG triangle, this ABG triangle and this BGXY. Okay, they are on the same base BG and between the same parallels BG and AX. Therefore, this area of this triangle will be equal to half of BGXYC. This is the third condition. Using 1, 2, 3, what you can prove? These two triangles are already equal. Okay, then they will, this half of these two squares are also equal. Okay, then ABD area will be equal to the rectangle BGXY area. Okay, similarly you can prove this ACHY area is equals to CFXY. Now see, how will you get this BCFG area? You have to add these two rectangular parts, no? BGXY you have to add and CFXY we have to add. Then only you will get the square area. But here already you have proved BGXY area is equals to ABDE. You can replace this with ABDE. And also CFXY you have proved that this is equal to ACHY. You can replace with that. See, now what you have proved? Area of this square is equals to sum of the squares of these two areas. Okay, here see this square, how it is defined on the BC square. So its area will be equal to BC square. And ABD, how you have defined? You have defined on the side AB, that will be equal to AB square. And this square is defined on AC side. So that area will be equal to AC square. Here see, BC is nothing but the side opposite to 90 degrees. It is hypotenuse. So we have proved hypotenuse square is equal to sum of squares of other two sides. This is nothing but Pythagoras formula. The same theorem you will prove using similarity criteria in 10th class. Okay, it can be proved by activities also. In next video, we'll show all activities, how to get the area of a trapezium, parallelogram, rhombus, and Pythagoras formula also. We'll do activities and we'll show you. Okay. Please like and subscribe for more videos. Okay. Thank you and Jai Hind.